and welcome to our service announcement, driving in precipitation. Whether it's obvious or not to you, friction is present when driving a car. When it rains, snows, or is icy on the road, your car tends to be at a higher risk of skidding or hydroplaning. When roads are dry, your car has higher friction, which keeps it in control. Let's take a look at our demonstration.
The friction between the tires of your automobile and the road determine your maximum acceleration and, more importantly, your minimum stopping distance. That was an example of driving on a dry road. The tread designs channel water away from the bearing surfaces on wet roads to combat the tendency to hydroplane, a condition which allows your car to ski on the road surface because you have a layer of water lubricant under all parts of your tire.
Back to our service public announcement. And that was a demo of driving on wet and dry surfaces. The reason we were able to control the cars at all is because of friction and between the car's tires and the road. More accurately, because there are three kinds of friction: starting, rolling, and gliding or sliding. Sliding friction between the wheels and the pavement is the villain of the piece, while total rolling friction and starting friction allow the car to be under control. Both starting and sliding friction between wheel and road are gently reduced with ice. So within the brakes, however, starting friction does indeed cause a problem. This is our second demo. The tape represents the object on the board, which represents the friction. As the tape is dry, it sticks to the board with friction. However, as you will see, when we apply water to the adhesive in the tape, it reduces the friction and causes the ball to roll down the board. Now we are going to apply water to the ball. Notice how, when water is applied, the reduced friction causes the ball to roll down the board.
And that was our second demo. Applying this to a car on ice takes one more definition. The effective rolling friction of a car's wheels involves not only the rolling friction of the wheel itself, but also the various sliding and rolling frictions of the brakes and bearings. For a car to start moving, the engine must apply enough force to overcome the internal friction of the transmission and bearings and start the wheels turning. It must do so without letting the wheels apply so much force to the road that they overcome the starting friction of the wheels on the road and start spinning. Now let's see our third demo.
Demo number 3. You've seen driving in precipitation and decreased friction with the ball on the wood, but do you think that this pan, this penny, and this olive oil will increase or decrease the friction of the penny sliding in the pan? Here is our pan and here is our penny. This is without the oil. It is an empty pan and clean. We take the penny and put it at the top of the pan. What do you think will happen? Well, let's check it out. Whoa, did you see that? It went down without ease. Really no friction. But watch this. We take our olive oil and pour it in the pan. Give it a good stir. Now, once again, we tip the pan, take our penny, and put it in the pan. Watch this. One more time. A total increase of friction. Can you believe it?
And that was our third and final demo. Now, one would think the penny in the pan relates similarly to a hockey puck. on ice. But that was not the case. There was an increase in friction because it is a thick substance which causes the teddy to move slowly down the pan.
So, we learned that work equals force times distance. Work is the product of the force exerted on an object and the distance the object moves in the direction of the force. You know, that's very similar to when we drove the car outside.
It is.
And the car exerted a force, and on the dry road there was more friction, but on the wet road there was less friction. In conclusion, our 3 demos showed how friction affects driving on wet and dry surfaces. Thank you.
Bye.